Well, this is my autonomous mower project I've been working on. I shouldn't say project, it's probably more an obsession now, I think. I'm not sure when it stopped being that, but it's been an interesting and fun project to work on. This is what I came up with. I was not going to get a system that actually had a wire buried or something like that. And what I did, I adapted my 20-inch Ryobi 40 volt mower. I had this thing already here. I wasn't really using it that much. I thought, well, to learn how this all works, because I was pretty much starting here blank slate, tabula rasa, and I thought, well, if I'm going to do this, I need to make some space for me to make mistakes and have an open system. So I have a lot of places to put things and change things around and configure things. And I will, once this is all done, get it configured and try to get things a little bit condensed and get the wiring covered up and stuff like that. But till then, I'm still in experimental stage. I got about 12 hours of runtime on this one so far. I've actually already using it for 3 different sections of the yard. I think if I can get the mowing 80% of the yard, I probably can take care of the other 20%. I do have a lot of trees, so I know it's going to be kind of a hard thing to do because of the interference there. But like I said, I'm already impressed how well this thing works, and I know it's only going to get better. Now, the reason I'm making this video now, I'm not done. I know that, but I've heard of software that my favorite line on software, that software is never finished. It's just given up on. And I think this is this project. It's never going to be finished. It's just going to be given up on. So, and I'm also making this because this is the video that I wanted to see when I was first starting. Okay, when I was teaching in school, I always tried to teach my therapist what I wanted when I was in their shoes at that time. And I thought, well, I'm going to try to apply the same thing here too. So if I make too many mistakes, say too many times, I'm sorry about that, just too bad, the way it is. So this is the system, this is it working here too, and this is really a mistake, I think. I think it's lost the GPS lock right here, because when it gets close to the waypoint down here, it's going to veer to the right a little bit. Now what you're seeing here, this line here, this is when I flipped it on to auto. It went over to the first waypoint. It's been working its way back and forth. It's really been doing a real good job. It's leaving a little bit of strips here and there, but you can see how it's just veering right now. I think it's going to reacquire, and it's going to come right back to me, mowing right where it should. It is very slow, and I will be speeding it up. But right now, I kind of like that slowness because, well, if I have a bad robot, I don't want a fast bad robot. So it's going to be slow. And again, it's not that slow. I can just kind of walk away from it. This is the first time it actually mowed this particular yard, and I didn't have to do anything the entire mow till it started to the very, very end. So that shows me there's potential here. I'm getting a little jerkiness in the video here too. I hope it doesn't transfer over to the finished one, but we'll see. I know this is like paint drying. Sorry about that, and I'll move on a little bit. The mower itself, I just removed the wheels, used the studs, and they bolt in. They actually hang into some structures at the bottom of my gantry system, because this is a gantry I'm using just to haul this mower around. There's a bumper in the front, so if it hits something, it's going to shut off and it's going to shut the blades from stopping. And I'll try to get in to discuss all these parts later on. Yeah, it's mowing where it should mow now. You notice I'm running two dual 40-volt motors, or batteries, I should say. And I'll talk about that because I've actually been able to gang them together with ideal diode circuits. Yeah, it gives me a lot more run time than just a single a single battery. And again, if I was going to use a gas mower, you're not going to get that much more runtime out of a small tank of gas. Well, enough of that. It's just going to keep on working around here. So this is the Autopilot mission planner side of it. It really follows the line right very well. I do get kind of funky stuff going on my waypoint turns. And I know right now my waypoint turns are very slow. I will probably, and I have actually, I've sped it up a little bit, and I do like this back and forth. I found out that Spyros, because of the extra waypoints, I think my turn is greater than 20 degrees. We'll do a pivot turn right now. So I know I have a few more things to adjust on it, but I'm happy to get it tuned so well at this stage. I did not use the new tuner. Actually, this is the old style of just watching it and looking at it and what basically it was set up on the videos I saw. It will adjust over here. It does say bad compass health on the top up here, but I'm not using the compass. This is all GPS by Yah. I'm real fortunate to be close to a mile and a half away from a transmitting tower I get my N-trip from. I live in Iowa, and it's a free service. Thank you, Governor Culver. That allows anybody to use it free of charge in Iowa. I do have it dropping sometimes. In fact, sometimes I can go back and see all the satellites red and nothing transmitted, nothing received. So I'm not exactly sure why that's happening. Things are happening, and to be honest, I've not reviewed that log where it lost. That was just last week, and I've been busy with other projects. But enough of this. This is that funky turn, but as long as it's a consistent funky turn, it seems like it keeps on mowing the next area over and next area over. So it's been good. So let's go the other way here. So this is it. I built this gantry system. I did not want to reinvent the wheel. I did not want to reinvent the lawnmower. So I built this gantry system to hold my existing Ryobi 40 volt 20-inch mower. This is the mower I had. I thought, well, I wasn't really using it that much, so this would be a good place to start. And I built this open frame, open area, because I knew and I've changed it so much. I'm glad it is so open, because I've made several mistakes, and so it's one step ahead, two steps back, and I've changed the things around enough that when I do get it all done, if that ever happens, I will condense things down, cover up the wiring, keep the dust and crap off of things, and keep things a little bit safer for electrical. But the 6061 aluminum, 1/4 inch by 2 inch and 1/4 inch by 1.5 inch is how I made my frame. The gantry system, I do like using aluminum. It's a little bit more expensive, of course, but in many ways in time it's cheaper. It's actually a lot cheaper aluminum when you buy it in 20-foot lengths. But if I would have made this in steel, one, it would have been much heavier. Two, I would have had to spend a lot more time finishing it, sandblasting it, getting it protected from the environment. Whereas aluminum, I weld it, wire brush the welds, move on to some other project. So I do like aluminum. Let's see anything else in this picture. I think we'll move on here. Now I made the top removable. Okay, and I really like that, because on my motor control unit, my Cytron, it talks about in there, do not push the wheels with the power off. That will generate a spike, and you could potentially damage that controller. So what I did, I made the top completely off, removable, and all I have to do is just connect a couple lines from the mains back here on the motor controller at this stage anyway. And that way I could just take it on my deck and try to figure out how everything works. And it's been a lot of figuring. This is my third, this is an earlier picture. I've been through 3 GPS systems. I had a Here 3 that was bundled with my Orange Cube Plus. I went ahead and bought this Hollybro Mosaic H system because it touted easy configuring, and I thought, okay, after about a month or so of banging my head against the wall, I'm still wondering how they said that. I have to say I do like the Hollybro system. It works great with the RX tools that Septemtrio has put out. Really accurate, but it doesn't it just didn't seem to play well, or I could not get it figured out to play well with the Mission Planner Autopilot. I was hoping to find a video online that someone could, can show me how it was done, and there's nothing out there that I can find. I tried to build my own, but what I did, I got so frustrated with it, I ordered this CUAV, the C-RTK 2P dual antenna system. And I thought, well, I'm going to keep on fighting against the Holybro system until that system, my new receiver came in. Well, the CUAV receiver did come in, and within 24 hours, I was up and running with it. Curiously, though, why it took 24 hours is that I could not get the CAN interface to work. It has a UART interface, and so actually I had to put the UART interface into the serial 2 on the cube. Boom, it worked perfect at that, but I don't know why. I was curious, and so I disconnected the CUAV unit and hooked in my here 3 unit just to make sure the cam was configured right, and it found it right away, but for some reason it could not find this one. But it works great in the serial 2. It talks about 0.8 centimeters or something like that. I haven't really checked out that, but I only have a 20-inch mower, and it's actually not leaving too many streaks. So I'm happy right now. So this is actually how I build it. This is I use these are Invacare wheelchair motors I had from a wheelchair teardown a few years ago. They are 24 volt motors, and I'm only running this with a 12 volt system. This is a deep cycle 12 volt AGM battery. I did build the frame strong enough and big enough I can put another battery up here to take it to 12 or 24 volts if I wanted to. My motor controller will handle up to, I think, 40 volts or something on the specs, but that would not have been a problem. And what I did for my chain adjustment, this is just 2 pieces of steel tubing that telescopes, and I put this little lead bolt in the top here, this threaded rod, and there's a washer that just fits on the inside of the outer square tubing, and I can force that inner tubing down and apply my tension. I've never had this thing derail. It's been working real good. What you can't see, there are a couple bolts on the inside of this, on the back side, that once I get the tension right, I'll tighten them up. That keeps the idler bearing down here from moving and spinning around. I also had to add some spacers in the bottom here through the bolt here just to get that idler bearing on the very same plane as the rest of my sprockets. But so far, it's been working just fine. How I attach my motors. What you're looking at here is a 2-inch by 4-inch piece of angle iron. The leg under the frame is 4 inches. I had to build that up by welding on another 2-inch section. These 3 bolts here go through the frame into the motor, because there's 6 bolts to hold the motor. These outer bolts actually just hold the angle iron I built, and then these 3 bolts here also go into the motor, but they are just supported by that outer frame. That works extremely well. I have no problem with this. It is extremely solid. So moving on from there, what is curious, the motors here from this Invacare system are metric. In fact, it was 17-inch millimeter shaft. Well, I had these chains and these wheel sprockets from an earlier project I never used, and so I used them for this particular project, and they were all 35 type chain. And boy, that's mixing cultures here, metric to standard, and I could not find any supplier of a 17 millimeter shaft for a 35 millimeter chain. I found one for 45 through a robotic organization that they were making their own sprockets. And I looked around, I found a couple companies that would make them, adapt some for me from a MasterCar. Price was insane for just a small run. So what as an experiment, I 3D printed some adapters. And I have to say, I'm shocked how well they're working. Now I did make them on a PETG at 100% infill, so they're solid chunks of plastic. And on the 12 hours, I've checked them a couple times. They're still just as solid as they were. They give me the indication they might last a long time. I could, if I really wanted to, probably switch over some type of fiber fill carbon and print up something really tough. But I don't know. I'm not gonna I'm not gonna fix this until it gets broken. I'll keep on checking it, but I am shocked it's working so well. Okay, now this is the wheel bearings, sprockets, tires I got from Northern Tools for a project a couple years ago that never got built, and I thought, well, I'm going to put them in this project. Of course, these tires that came with it were way too small. I need a little bit higher tires. So I found out this wheelchair I tore down years ago had Invacare wheels with 4 lugs. The new versions now have 5 lugs, but the old ones had 4 lugs, and they were a perfect bolt on to the system I had. So I actually had to get a couple more. Went to eBay and found them really quick, and it was shipped right here without a problem. The sprockets, though, I found out the AZ USA sprockets, they will make any sprocket. So if I wanted to go back and look at that sprocket, having trouble with it, I could switch it over to a metric and then re-switch my chain and then get some metric sockets that'd be appropriate for it. But right now I'm going to move on to something else. But I have to say it's good. Now, how I did there, what you can't see here, there's on this 3/4 inch shaft. I welded that to this 1/2 inch by 2 inch wide piece of steel. I just didn't think anything I could do with aluminum was going to give me the strength for the bumps and all the stresses over for the next few years. So this was a lot better system, I thought, and I used grade 5 bolts to bolt it to the frame, and it's really strong on this area where I bolted it to. You really can't see the shaft here, but there are some shaft stops, the little pieces of metal with the set screws on them inside here, and there's 2 of them on the outside of the tire, and that gives me the impression that that will never be a problem. So that's I'm happy with how well that system's working. So this is my Smart Drive Dual 30. It is a 30 amp system, I believe, and it's about the closest thing to plug and play that I've ever experienced. In fact, when I got this thing originally right out of the box, I just plugged my RC unit, the receiver, into the RC inputs here, and even all the dip switches were just already set in the right position, and I could just control the motor right away within 15 minutes. You have to use a battery for the power supply. You cannot use a bench power supply. It's got some peculiarities in the wiring. Also, there's no reverse for the wiring here, so if you do unfortunately turn it on, reverse wiring, you're going to definitely release the blue smoke. Don't go there. Check and recheck. The hookup I have here, this is from my Orange Cube. This is where my main 1 and 3 come from, where I get my signals from. The same place where you're hooking up the RC place. I'm not using any of the UARTs, or I'm not using any else of the connections here. I'm just using where the RC goes in. So, and this is with a Orange Cube. This is where my main 1 and 3 originated from, main 1 and 3. And I send these signals right to it, and boy, I just tell you, it's been working great. I'll talk about the rest of these when they're coming up. I have added a fuse and a cutoff switch going to the motor controller. I will be adding a solid state relay. I've just not done that yet. I realize I want this completely cut off when the bumper hits something. Right now, when the bumper hits something, it just tells the Orange Cube to stop going forward. Not the best practice, but what I got. This is the switches I had earlier on when I was first experimenting around with learning how the wiring of the Ryobi mower logic worked. And one was just a momentary switch, one's off and on for the safety switch. I'm using a 12-volt AGM cycle battery. I get several hours of runtime out of that. That's why I don't think I'm going to be adding a second one. 10 gauge multi-strand wire from leftover from a solar project. Plenty of wire there. I do like heavy wires for DC. especially multi-strand. They just work better. Now here, as long as I got this picture here, that's one of the bolts I have on the inside that I can tighten down to hold that idler sprocket on the chain tensioner. So, okay, this is how I set up my jumper switches on the Cytron board. I've used other Cytrons. I do like these boards. I've never used a smart controller here, but it works well. And I've also noticed I have a mistake here. On 7 and 8, if I look down here at 7 and 8, well, the 0, 0 off and on, that's a LiPo battery. Well, I'm using a lead acid battery for the monitor, but I'm not really monitoring anything anyway, so I could probably just switch them or leave them. So it's not a problem. The first 6 are probably the most important ones, I think. How you telling it where the signal's coming from and what type of signal it's going to be. So that's how that works. If you just want to use the RC and don't even use Autopilot, that's a real simple one, because here's the RC controller. Put it in the same place. Make sure you have a battery, like I said, and this is the configuration for the dip switches that come this way out of the box. And next thing you know, it's just running quick. It was really fast. Okay, now instead of using the switches that I showed you, I'm using relays. I wanted to give control of the starting the mower and stopping the mower to Autopilot. So I'm using aux 5 and 6 for the relays here. You don't see a ground on the second one here because it's a shared ground. I'm going to the relay, and I did not need another redundant ground going to it. This is the relays wires coming from the aux into relay 1, relay number 2. Now the COM normally closed. This is my safety side. And I have a video coming up that'll discuss the logic wiring of the Ryobi. But there's the safety side that's all the switches are closed. If you release the handle, the motor stops. And there's a start side, the normally open switch. That's the one if you push the button, if everything else is closed, it starts the mower up. Well, I'm giving this total control to the Autopilot system so it can go to the waypoint. And once you're there, then it'll start the mower up, run the whole path, finish the mission, turn the mower off. Now, for the voltages, I think I'm running 4.4 volts. I had to look around because the signal strength coming from the orange cube is not strong at all. And some of the relays would light up the lights but wouldn't really trigger, even though I'm supplying the power for this from a different system. There's no power, of course, from the orange cube. And so I have a step-down relay in here that's adjustable. It says 3.5, but it's really, or 3, it's really running 4.4 or something. And I just adjusted it up so it would trigger. So that worked real well. And this is how I set the relays, turn them on. Do set relay, and this is in case it's relay 0. Strange nomenclature in the documentation. 0 is really 1, 1's, but do set relay 0. It turns it on. I have that's like pushing the button, 2-second delays, and then I release the button when I say relay 0, turn it off. That's after I start my first waypoint, and then it'll follow all the rest of the waypoints. And at the very bottom down here, you're going to see a do set relay number 1, and that's going to turn on the relay, open up the contacts, and then shut the mower off. So I'll talk about that. Now, this is the side yard that I use. I just drive my manually drive my mower around. I have a little lever on my transmitter that I can just push, and it'll save that waypoint. And then I take it back to the mission planner, and the developers have made this great project, a program that you can just kind of say, okay, this is the survey grid, and it will figure out exactly where you want to go based on the spacing of the paths you want to mow. I have noticed that when I have a lot of turns, especially sharp turns, more than 20 degrees I have it set right now, it's really slow. For me, if I got the long turnaround back and forth, that works really much faster for my system. I am trying to increase the speed of my turns, and I've been successful with that, but that's a lower priority right now, and I will eventually get it, but I got some other things to do. But right now it's functional. Here's my bumpers. Okay, now first off, I'll show you the video of this. If this is a fiberglass rod, hopefully it won't break, aluminum rod open with fiberglass inside, And if I hit anything, it hits both switches, and there's another set of switches on the other end. This disc right here is just to keep it centered. These are all 3D printed. I just welded up a little piece of bar stock, welded it on to the end, 3D printed, and bolted on the system here. Now, some of these switches are normally closed, and some of these are normally open depending on where they go to. One set of switches goes to the logic of the mower. So if that contact ever gets broken, well, it's just like releasing the handle, the mower blades stop. The other switch goes to the autopilot right now, the orange cube. It just tells it to stop the motors. I will be switching out, like I said, now this is not the best practice, but it's what I got right now to solid state relay. The there's a still video of this, and one of the things I'm kind of shocked about is that we're building robots with sharpened blades whirling around, and I'm not seeing a lot of these bumper switches out there or safety stop things. Yes, there's a button on top, but I'm not going to be. I hope no. I would like not be able to watch this continuously while it's doing it. It should run a little bit on itself, but bad robots, and they do happen. So I wanted to go this route with the safety switch, and that's why I did this one. Now on my safety switch input, when that switch gets made to the orange cube, it just pulls it down to low. I've actually configured my aux2 as GPIO input, and so what it does, it takes that signal down to low, and that tells the orange cube, switch has been made. So that has been working well. There's a slight delay, of course. That's why it would be better to have the solid state relay to break the power when that gets hit. I also have added some enable switches. Okay, this is the switches from the relay, which I can actually disable the entire mower system until I flip the switches on. The reason for that is, I'll talk about this again later on, but when the orange cube boots up, the aux lines ports go high, and that can cause some pretty weird behavior, especially when I have that behavior or those voltages controlling a motor with a big whirling blade on it. So I've actually got this physical safety switch lockout enable system going. So once the autopilot is booted up, then I'll flip the switches on right before I send it away on the mission. Now this is also my voltage. I just 3D printed up a voltage monitor and a push button that goes to the battery, just so I can see what's happening there. Okay, now I'm gonna break here. We're gonna talk about the Ryobi logic. Okay, what you're looking at is a representation of how my mower was originally and how I adapted it so the autopilot can control the blade off and on. So originally you have 3 switches, and you can think about this as a safety circuit and a start circuit. On the safety circuit, there's 3 switches, all in series. There's one by the hinge, so the handles have to be completely open. There's also one inside the handles, so the handles have to be fully extended. And then, of course, there's a lever bar in the back that you have to have that held down. And if you got all 3 of those closed, let's close this here. Then if you hit the start button, the motor starts, blade starts going around, and you're fine. Then the start button doesn't really do anything. To stop it, one of these switches, of course, usually the lever bar in the back just has to be released, and that opens up the circuit and stops everything. So this is how I adapted my mower. This is a 20-inch Ryobi brushless mower. I put in 2 enable switches. These are normally open. Because the problem is with the autopilot or my orange cube is that when it powers up, the auxiliary switches or auxiliary ports are actually high for a few seconds, and they go back down to low once it finally gets initialized. And I didn't want any strange behavior, so what I normally do, I let this thing all completely boot up. Once it's booted up, then I'll go ahead and manually click the enable switches, and then the autopilot can take over. Now the safety switch on the relay 2 here, that's actually going to be onto the normally closed connection in common. That way when I do energize the coil, I can open it up and stop the mower. Or if I would actually hit something, then it would actually break the circuit as well. and that would then stop the mower blades from spinning. Now to start it, once it's got enabled here, all I really need to do is energize the coil here, and I think I got that on aux 5. And I have this thing triggered pulled down for 2 seconds, and it releases, and that will start the mower. One thing I have learned though is that if you just momentarily break a contact or even the relay for only a second or so, the blade really doesn't come to a complete stop. And if it goes back to the closed position again, then it just starts running again. So what I do at the end of the mission, I'll go ahead and energize the relay 2 here, and I have it energized for 10 seconds. Everything comes to a complete halt, and then basically to restart it again, I'd have to have everything closed again and then restart the start button here, the normally open one. But this has been working quite fine. I did have to kind of find the right relay. Some of the relays didn't have enough. The signal strength wasn't enough to actually trigger them. It would light the relay up, but wouldn't really trigger the contacts. So I had to kind of look through my relay drawer and find the right ones. I am powering these with a step down back, and I can adjust the voltage on that. But it's been working great, and I don't think I'm going to change anything. Okay, now from the Ryobi on the battery side, a single battery is not going to give me a lot of run time. And I found these ideal diode circuits, and that was just a perfect thing. Now I can put as many batteries as I want. I can gang them together or parallel them together. I don't care about the size of the battery. I don't even care about the charge of each individual battery. Most times if you parallel batteries together, one's higher than the other, it will actually discharge in the other battery, charging it back up, trying to equalize things, and that can cause all sorts of terrible problems. The ideal diodes they are, in a nutshell, voltage controlled switches with very low resistance. A regular diode will do that, keep the backflow, but there's a lot of resistance. You're going to get a lot of heat generated there and a lot of wasted power. These things are a lot better, much better on their resistance on. And what you're seeing here is that all the pluses and all the minuses are together, even though the color changes. I didn't have the thick red wire down here. That is also a black wire reference to the ground. So what these things do, the battery with the highest charge gets to go first. It will start working, and then whenever it drops down to what the other batteries are, then the other batteries will jump in and start and give their all to it. Now I can probably put a lot of batteries here, but right now I'm only running 2 batteries. And how I connected these up, I 3D printed these cases. In fact, if you go to Thingiverse OT and AT, that's my 3D printed channel, you can actually download this one already. I've not actually added this one because this has got a third contact. On the Ryobi battery itself, there's a T1 and T2. I believe these are temperature sensors. And there's actually a small red wire inside the mower. What I did, I took the case off the mower to get all the switches and everything open. And I just disconnected the mower battery connector and added my own, what you're seeing here. And then brought that out so I can just kind of plug the batteries in easily. This is kind of my main mower with the T1 connected to it. So I make sure that's always connected if I'm only going to use one battery. But I've been using a second battery, and it's nice because both batteries will kind of equally fall now. If I'm done with the mission, I might have 2 bars left on each battery. Now I'm running a 6 amp hour battery on one and a 4 amp hour battery on another. I'm getting well over an hour runtime. I have just bought a new riding Ryobi mower that comes with 2 80-volt motors, but it also comes with 2 40-volt motor batteries, I should say, that would actually plug right in here, and those are 12 amp hours. So I probably, in theory, I don't know, 3 to 4 hours, maybe more runtime, more than I really need. So I could use those batteries for that. So anyway, the ideal diodes are, I don't know, I think I got them from AliExpress for $5 or something, shipped right here. You get the ones with the terminals already mounted on. It makes your life much easier. Again, like I said, I probably will be covering these all up once everything is, completed or close to completed. Okay, the ideal diode circuit, I think I've covered that enough. Yeah, every battery has its own little ideal diode circuit. You can't, don't cheat. Everything's got to be connected the same way. Now, this is what's going to be future plans. Okay, this is the thing I just got 3D printed. I've not got this mounted yet. The problem I'm running into is that I don't know when my RTK lock has been dropped. I do know if I'm watching the screen here, but that's not where I'm out in the yard. So this is a little 3D driver, a 3D printed LED driver that I'm hooking up to another aux line I have. And I've just got into Lua programming, written a couple small simple programs just to get prepared for this. But this is something I think I think other people could use this too, because what this would do, as long as I got an RTK lock, I want this LED light on. It's a really intense green LED light that I could see in full sunshine. And if I got a high coming from the aux line, that's representing the program. It would say turn that relay on. If you lose the RTK lock, turn it off. Because I don't know when I'm physically driving my rover around the yard, making my waypoints, if I truly got an RTK lock at that time. I got a real inexpensive RC unit, kind of a starter unit. It does not give me any of the displays from Mission Planner, which I see some of them have now, which is really cool. But that's um, that's to be implemented. And I'll come back and post something on the forum when I finally get that far down the road. I'm also going to be increasing the speed on this thing. Like I said, I got those sprockets ready to go, and I'll come back and visit this. But I don't know. I hope people find this useful. My apologies if I've made some mistakes or too many ums and twos. That's just the way it goes. The project has been a real lesson, a little learning experience for me. I cannot believe how much I've had to learn to get from there to here. So if this helps somebody else, well, more power to you. Questions, concerns, outrages, don't hesitate to drop me a line or make a comment. I will post any and all of these things of the 3D printed designs I have, because I have my telemetry units now 3D printed and being held by that, and everything. I got a lot of 3D printed stuff here too. So if anybody wants any of these things, just let me know what I can post them on my Thingiverse channel. So anyway, hope this helps.